multiplied by the number of species 1. Okay, now this part is really important. So if you haven't quite gotten it... What? Okay. Okay, I'll give you just a second to catch up. I do want to kind of push the pace here because we don't have a lot of time to get all the way through predation also. Okay, so even if you don't have it all the way coded in, just watch this part, okay? So, once you do have your first two cells ready, when you're ready to run the simulation, you cannot do each column separately, okay? Because the columns are using each other as a cross-reference. You have to click and highlight both of these cells and then drag them down together. You have to do it simultaneously. Uh-oh. That doesn't look good. I might have done something wrong. Oh, that's right. I forgot to put these in. Okay, so I'm just going to use 1 and 1. Okay, so then once you have the simulation done, and so at this point this is great because you can just change these coefficients and the numbers will change for you, okay? And so if you just go ahead and make your graph, okay? So just highlight all the data, including the labels to the columns. Go to scatter plot. Do not use the line graph. The line graph doesn't give you the right result. Go to scatter plot and use this option that connects it with smooth lines, and then you get your graph. And now what's really cool, because all the constants in this equation are held constant with those dollar signs, you can actually just highlight these two cells, and then you can just do the same thing. Highlight both cells and drag them down together. Make sure that's right. Okay, now anytime you change this, it's going to change the graphs accordingly. So now I've already went ahead and got this all done and cleaned up, and I did it so that I can hide the alpha values because I don't want you to know any of the answers. So basically what this shows right now is, actually let me just change this to the top. So right now, this is what happens when species 1 this is coexistence. So because they have different carrying capacities, they're not going to settle at the same equilibrium value. But because they both equilibrate at a non-zero value, this is coexistence, okay? It doesn't matter that one population is higher than the other. As long as they're both persisting at a non-zero value, that's coexistence. So this is going to be one of your 4 options. This is what you want it to look like when you're showing coexistence. On the other hand, you might have species 1 or species 2 outcompete species 1. Okay? And so this is what you would see. Species 2 ends up going to carrying capacity, species 1 crashes to 0. And it doesn't matter who starts at a higher level. See, in this case, species 2 started at 5, it went up to carrying capacity. Here it started at 50, went up to carrying capacity. In both cases, species 1, even though here it did well at first, it still ends up crashing to 0. So this is species 2 outcompeting species 1. The other way, you'll just find the values of alpha and beta so that this is reversed. Okay? And this is what you'll want it to have, although, of course, you want to add a title and axis labels and all that good stuff. The final thing you want to show is that alternate stable states. Okay? And so this is what the alternate stable states will look like. In this case, species 1 wins. In this case, species 2 wins. And it only depends on who starts out at a higher population level. Okay? Neither one is necessarily going to outcompete the other by virtue of any intrinsic quality. It's just a matter of who gets the jump on the other one. So this is what alternate stable states will look like. So again, just get your 2 runs set up. And once everything is coded and you have the graphs there, you can just start playing around with different values of alpha and beta to generate these 4 different outcomes. And then again, you'll want to have 4 sheets for competition, 1 sheet for species 1 winning, 1 sheet for species 2 winning, alternate stable states, and finally coexistence. Make sure you have it well labeled, and make sure you show me exactly what your alpha and beta values were that you used to get the result that you had. Does anyone have any questions on competition? Okay, I'm going to give you like 5 minutes to work on your competition, see if you run into any snags and ask me questions. Then we're going to roll right into predation because we don't have a lot of time. Okay?